Hi everyone, today I'm going to lead you through some ideal gas law calculations involving molar mass and density. Let's get started. By the way, this is heavy in algebra, but I hope you stick around for some shortcuts that are going to really help you out. So some important equations. We remember that molar mass is the same thing as mass divided by moles. Now, we use this kind of italic capital M to say molar mass instead of a capital M, which is used for something else in chemistry. For mass, I've got M, and for moles, I've got N. Now, you might think that mass should be G, and I agree with you, but since we are using the ideal gas law, I don't want to get G confused with mass in the density equation, D equals M over V. So I'm going to keep mass as M, and always remember that molar mass is this capital italic M. We, of course, remember that density is just grams divided by volume. You might be used to using milliliters for density, but since we're using the ideal gas law, our density will be in liters here because we have to use liters for the ideal gas law. Finally, the ideal gas law, you all know, PV equals nRT. Units are important here. Now, when I get to the final step of each problem, I did not use the units because it wouldn't fit on my screen, but it is essential that you choose the correct numbers, otherwise you will get a wrong answer. So choose the correct R to match your pressure unit. Volume must be in liters. Of course, temperature must be in Kelvin. And density, when we calculate it, will be in grams per liter because we are using the ideal gas law to answer these questions. Here we go. A 252 milliliter flask at 18 degrees Celsius has 0.48 grams of gas at 750 torr. Torr is a unit of pressure, and it's the same as an mmHg, millimeters mercury. What is the molar mass of the gas? So on the left-hand side, I'm going to organize my information. Feel free to pause and rewind. I'm going to go through this kind of quickly. So let's organize our info. We know that the ideal gas law is PV equals nRT. We also know that molar mass, capital italic M, is equal to grams, but I'm using M for mass, divided by N, which is moles. The volume is 252 milliliters. And when I convert that to liters, it's 0.252 liters. The temperature is 18 degrees Celsius. So when I add 273, I get 291 Kelvin. The mass is 0.48 grams. That should say an M and not a G. Sorry about that. And the pressure is 750 torr. And they did put a dot after that zero, so it is 3 sig figs. And the R that we're going to need to use is the one that matches torr, because the torr is the same as an mmHg, so that is going to be 62.4. All right, algebra alert. We have got to do a lot of rearranging here and substituting, and it's not going to be a whole lot of fun, but hang in there because I'm going to give you a shortcut after we do this problem and the next one that will help you out a lot. Molar mass is mass over moles. Let's rearrange that and get mass by itself. So mass is the same as molar mass times moles. Now we're going to rearrange PV equals nRT to get N by itself. So remember, if you need to pause to look at this algebra, you are welcome to do that. Notice there's parentheses around the RT. That's going to be very important when you go to type that in the calculator. If you see parentheses in this video, they are important. Okay, so here's the heavy lifting. What I've done is taken what N is equal to, remember N is equal to PV over RT, and I have put it into this equation. So instead of N, I've switched out with what N is equal to, PV over parentheses RT. So this equation here is still true. Molar mass times pressure and volume divided by parentheses R and temperature is going to be the same as R mass. I hope you can see what we're trying to get at here. We're trying to get this molar mass, italic capital M, all by itself, because that is what the question is asking. What is the molar mass of the gas? Let's clean it up a little more. Let's get rid of this RT that's in the fraction in the denominator on the left-hand side by multiplying both sides by RT. That moves it over to the right-hand side and makes it a little bit cleaner. Finally, we're almost done. To get M, a capital M, italic M by itself, I'm going to divide both sides by PV. And I finally get my equation I'm going to need to use. The molar mass is M times R times T over quantity PV. So make sure you use parentheses there. I'm going to plug in, and I'm not using units here, even though you really should, but I am going to check that my units check out. So the mass in the problem was 0.48 grams. 62.4 was my unit for R. And since a torr and an mmHg are the same thing, I can use 62.4. 291 was my temperature. Divide. This parentheses right here is critical when you type this into the calculator. So left parentheses, 750 was my pressure, and 0.252 was my liters. So I used, just to double check my units, I used liters, I used Kelvin, I chose the correct R, and what would the unit be for my answer for molar mass? It should be something like grams and moles. So my 0.48 there, it gives me grams, and my moles is in the R. So the moles will be the only one that's left over that doesn't cancel out. The pressure cancels, the volume cancels, the temperature cancels. Wow, that was complicated. And when I plug in, I get 46 grams per mole, 2 sig figs. Remember, hang on and I'll give you a nice shortcut in a second. Let's move to the second problem. A balloon has helium at negative 13 degrees Celsius and 450 torr. And the helium is going to be important here. It's easy to miss that because you don't see a number there. What is the density of this gas? And then there's a second part of the question, which we'll answer in just a second. So just like the last problem, I'm going to organize my info. Feel free to pause if you need to. I'll be using the ideal gas law, PV equals nRT. I'll also be using the density equation, D equals M over V, because it's asking for the density of the gas. I'll also be using the molar mass equation, capital italic M, molar mass, equals grams over N, moles. I should have used an M there instead of G, sorry about that. Our temperature is negative 13 Celsius, which comes out to 260 Kelvin. Note the period there gives my Kelvin temperature 3 sig figs. My pressure is 450 torr. Notice the problem gave you a dot after the 0. That makes it 3 sig figs. I'm choosing the unit of R that matches my pressure unit. It gave us torr. Once again, torr is the same as mmHg, so I'll be using 62.4. And here's why helium was important. This number is not in the problem, but since we're going to need the molar mass of the gas, I've got to look at the periodic table and find the molar mass of helium. And when I look at the periodic table, it is 4.00. Okay, another algebra alert. First, I'm going to rearrange my molar mass equation. I'm going to get mass by itself this time. So when I multiply both sides by N, I find that the mass is equal to the molar mass times the number of moles, N. I'm going to need to rearrange the ideal gas law. This time I'm solving for volume. So when I get V by itself, it's equal to nRT over P. Now we get to pull out the density equation. Density equals mass over volume. But I just figured out what mass was equal to. It's equal to this, M times N. So I'm just going to plug in molar mass times N instead of my M. And we just found out what volume is equal to. It's equal to this, nRT over P. So I'm going to be really careful with parentheses here, and it's going to look really ugly. But algebraically, look at that. Density equals molar mass times moles divided by parentheses, moles times R times T divided by P. Wow. Do you notice how we have moles in the numerator and the denominator? They cancel out. So at least we get to clean it up a little bit. Molar mass divided by important parentheses, R times T over P. I'm not going to put units in because I don't have enough room, but I am going to check that I use the correct units. 4.00 was grams and moles. 62.4 was my unit for R. 260 was my Kelvin temperature. If you try to use Celsius, you will get it wrong. And 450 was my pressure unit. And notice all of these crazy parentheses I'm having to plug into the calculator. I actually use brackets instead of parentheses here. So when you type this in, you would go 4.00 divide, left parentheses. Don't try typing in a bracket. Type it in exactly as you see it, except instead of a bracket, use the parentheses. Are you ready for that shortcut yet? Because I am. When you plug all of that in, you'll get 0.111 grams per liter. And we can easily answer the second part of this question. So the density of air at that altitude was 0.85 grams per liter. Our helium is 0.111 grams per liter. So yes, the helium will float. All right, are you ready for the shortcut of the year? I did not come up with this. Do not complain about this being a silly mnemonic device because I did not come up with it. Molar mass equals dRT over P. I would highly recommend memorizing that equation because it will save you from all of that algebra we just had to do. Here's how to memorize it. It's a meme, of course. Molar mass kitty cat always puts dirt over her pee. Molar mass kitty cat always puts DRT, dirt, over her pee. I did not come up with it, but it is helpful. Here's another one for the other equation. What about the density equation? Density equals PM over RT. Pressure times molar mass over RT. Dreams push me over rough times. Sad dog. Dreams push me over rough times. The over is like the fraction bar. So let me show you how much simpler it is when we use these shortcuts. Molar mass kitty cat always puts dirt over her pee. Let's write that as the equation. Molar mass equals dRT over P. Do remember that density is mass over volume. So see how I just plugged mass over volume instead of my D? And if I plug in carefully here, I know it's a lot of numbers, but at least we didn't have to do all of that crazy rearranging. We get the same answer, 46 grams per mole. Don't forget, for molar mass equals dRT over P, you still have to use Kelvin, you still have to use liters, etc. What about the other problem? Shortcut, dreams push me over rough times. Dreams, D equals PM over RT. 450 times 4 divided by, if you're plugging into your calculator in one step, you need the parentheses when you get right here. 62.4 times 260, density is 0.111 grams per liter. I hope this show has been helpful to you. I know these types of calculations are tedious, but with those two shortcuts, we make it as easy as possible.